Hello, good evening, everyone. So welcome to the second part of the MYP design. So today I'm going to talk about how do you finish the reporting part for the portfolio on Criterion B, developing design. Developing ideas. So in this case, there are again four strand indices criteria, which is the first strand is developing design specification, which clearly state the success criteria for the design solution. You also need to develop a range of feasible design ideas, which can be correctly interpreted by others. So interpret by others is very important. So you also need to present the chosen design and justify its selection, preferably quantitatively. And lastly, develop accurate and detailed plannings, drawings, diagrams, and outline requirements for the creation of the chosen design. So for achievement level of 7 and 8, the students need to develop detailed design specification, which explains the success criteria of a design of a solution based on the analysis of the research. So this research will be done in the previous Criterion A, where you talk about research plan and your design brief. Second strand, you need to develop a range of feasible design ideas using appropriate mediums and detailed annotation, which can be directly interpreted by others. So then, from that range of feasible design idea, you present the chosen design and justify fully and critically its selection with detailed reference to the design specification. So lastly, of course, you develop these accurate and detailed planning drawings, diagrams, and outline requirements for the creation of the chosen solution. So look at here, there's a develop accurate and detailed planning and outline the requirements. So for the requirements for creation, you don't have to go into specific. However, for the planning drawings and diagram, you need to be very accurate and you need to be very detailed. So in here, I actually want to thank Mr. Stevenson, MYP Design Classroom from Bavarian International School in Germany. So he has actually created a wonderful website where in example material, you can actually look through all the example of how you do individual strands in Criterion B. So let's go to design specification. So this design specification actually is a set of constraint requirements and consideration for a problem. So in this case, if you download the template that I uploaded, that will be the first section that you have to go through. So of course, the template will have the cover page and the table content as accordingly with the last video that I show you. In design specification, it's just what are different aspects and what are the different descriptor of this aspect. So if you go back to the website over here, you can see that there are the constraint requirements and consideration of a solution in different aspects. So what you return must be specific, measurable, achievable, realistic, and testable. So what does this SMART means is actually demonstrated well in this example. So what is a poor example of design spec is like my storage must looks good, nice, which doesn't actually mean anything because the term used is very subjective. So it must works well, doesn't make any sense, nobody understand what you mean. So my storage device must be the right size, very difficult to understand as well, and so on. So instead of writing how is it that it looks nice, you can actually say something like this. So the storage device must contrast with the furniture of the room. So bright colors such as red, yellow, and orange would work really well. So in this case, it's very clear we're using red, we're using yellow, and we must use orange in this situation. And we know that it could be a combination of all three or a single color. Very clear and simple understanding. So in this case, it must work well, very complicated and very vague for us to understand. But if you say the clock must display the time accurately, it's fairly straightforward. Everyone knows what it means. So this means that it is specific, it is measurable, yes, it's achievable, possible, and it's realistic and it's testable. So don't write something like black magic where your chair can fly or so on. So if you say that my storage device must be the correct size, is useless unless you're saying that it must be able to hold 20 pencils, which are 170 millimeters long and 8 millimeters in diameter. So this is very clear. We understand what do you mean. So same with my video must not be long. If your project or your product is a video, but you have to say that my video must be at least 1 minute and no more than 2 minutes. So that gave a very clear boundary of what you need to do. So if you are really specific and want to be very detailed on your design aspect, of course you can have individual aspect with their constraint requirements and consideration. So the first thing you might want to look at is the requirement. How does it need to look like? What's the texture you want. So if you're doing a chair, it has to look like a chair, obviously. It must to have four legs, or you must have wheels on there. The texture, it might be fabric, it might be PVC, and so on. Is the color black, white, yellow, and orange, and so on? What a constraint in aspect that you might face. You might not be able to make it too big. You might not be able to make it too heavy because you need to ship that and so on. The consideration is similar to the constraint just now, where if you make the thing too big, people might not want to buy it. If you make it too expensive, people will not want to buy it. If it doesn't look good, would people still want to do it, or do they not care? So that depends on the previous research that you have. So same that I have talked about just now. Is there a maximum cost of consideration that we want to consider? Is there requirements that we must keep it between 250 to 500 ringgit and so on? And who is it for? So the requirements for the customer is maybe a middle class adult that cares about sustainability, or care about the ergonomics of the environment, and so on. Are we targeting male or female in general? That would actually affect your color and your texture patterns in your aesthetic. So what are socio-economic status? Are they able to afford let's say 1,000 ringgit chair, and so on? So what are some environmental considerations? So if you're doing certain thing like a reclaimed material buildings, what the solution will be? Are you recovering just the steel or the plastics, or you're doing something like don't know, just use a more ecological way? So in this case, what are the constraint requirements and consideration in terms of the environmental aspect of your product? So function will be something like that. Do it has adjustable height? Are you using memory foam? Does your website do a certain thing or have a certain way? So it might have certain consideration on copyrights. It might have certain constraint on the size of data and number of users at once, and what kind of security system are you running on so that you don't run the DDoS attack. So manufacturing is slightly more complicated, because if you're going to make it yourself, and manufacturing will be a good big constraint, so that what resources are available to you and to you personally. Do you have a hot glue gun? Do you have a saw? Do you have a place where you are able to make your product? So if you are making a big table, that might be a challenge. If you are coding a software, or you're running some AI without some powerful computer, that will be part of the thing that you need to look into. So materials will be previously on the aesthetic where you describe. If you're using fabric, can you get a fabric? What kind of fabric are there? Which one is a better one? Should we use a soft fabric, hard fabric, cotton, nylon, polyester, or whatsoever? So safety will be slightly more personalized to your project. Just say you are running a chair. If you want your chair to have some safety features, such as when it breaks, the stem of the chair will not poke the user, because that poses a safety reason. Do you have a proper height, or do you have a proper safety mechanism, so that when people tilt, it doesn't fall over, and so on? So lastly is the size, where similar as I talk about in aesthetic. Does it has to be as big as a human? Does the size actually affects their operations or shipping or manufacturing, and so on? So these are the ideal condition that you want to go into, and what do you want your product to look like? How much do you want it to cost? Who do you want to sell it to? How do you want to have any environmental impact to it? What are the functions? What does it do? How do you make it? What are the material you want to use? What kind of safety things you want, and size? So there's two good example of design specification. So let's look at a good design specification of a clock project, which is very short, very straightforward, but has a very detailed idea on how, after you reading this, you kind of know how the clock will look like. So this will be the size and static. It must have a quartz analog clock movement. It must have larger than 55 times 55 millimeters. So it should be smaller than this. So it must be original design, that might be the manufacturing constraint, and so on. It cannot be too difficult to make, will be on the manufacturing as well. It must be cost efficient, will be the price. Should be easy to read, not very specific. I think they can add a bit more on this one. Should be safe, will be the safety consideration from the one we talked about just now. Must be able to hang up the wall securely. So that would include maybe a hook at the end of the clock, or just a place for them to put the strings on there, so on, and all that thing. So must be able to give time to be made in the time provided, and must tell the time I would say accurately is a better statement, and so on. So there's another general one, function aesthetic safety breaks down for a project of a skill game. So if you want to look at something like environment, should use the minimal amount of material possible, prevent wastage, so waste are kept to the minimum, and use recycled materials wherever possible. So these are not confirmed yet. These are just the ideal condition. These are the target that you want to go into your uh, section, which is the design ideas. So the design idea here will be very, very specific to your personal project as well. So the strand two is actually develop a range of feasible idea that be correctly interpreted by others. So how do you make it correctly interpreted by others is actually by annotation. So in this case, there are very many ways for you to try to actually convey the message. What we are doing this quarter is basically just a sketch on paper. So that would be the easier and fastest and more intuitive way that we can think of for you to convey a message. So we'll try a different method every quarter, and by the end of the year, you will able to choose what you want in the end. Okay, so in this case, for both product design and digital design, they usually start with a pen and a sheet of paper. So developing rough sketches of potential solution. So if you're doing something like a website over here, so this is a very good example of how these sketches look like. You have a middle part of the website with all these characters, all the colors and design, and you have all the annotation beside your original drawing. So it has a background that looks like this, it has a witch that looks like this, there's a tower looks like this, hair, there's animation looks like this, there's a prince over here that's climbing the thing, and there are button that when you have a rollover it gets bigger and so on. There's a waterfall, and all the required elements, all the possible element that you want to add into your website should be written down in your design ideas. So design idea, ideally you should have about 3 of them so that you can cross compare them. Okay, so in this case there are a few things, the few level that you go into. Initial concept drawing should be a 2-dimensional sketch to a 3-dimensional sketch, which include crafting, oblique, isometric, and projection, and so on. So it's just a different way for you to show the same product. Of course, you can go directly into 3-dimensional CAD models. However, it takes a lot more time, and it should not be classified as an initial sketch idea unless you are so good at it at CAD you can do it in half an hour or so. But otherwise, don't spend too much time making a 3D model where it is just initial sketch. It's also easier for you to start with a more basic version so that when you go into a more advanced level later in your final design, it'll be easier for you to convey the stories. Okay, so development drawings, as well, we have all this exploded drawing, and if you have a 3D design, that'll be pretty straightforward because you can kind of break them down and view them individually, their parts, their measurement, and so on. So you'll be able to get a very good idea of how individual parts should be manufactured if you have a 3-dimensional CAD model. However, it takes a lot of time, so make sure you have the final component before you go into CAD. So a criteria of the feasible idea is it's very subjective as well. So some of the questions you might want to ask yourself once you have developed your ideas, and how do you do it? So do I need to do more research to complete my design? Does the school have the resources for you to make the design? If you can't make it, try not to use it. It's very hard for you to do it later on. So do you have the skill to make the design? If you're doing a website, are you able to make the website or not? So will I be able to get the result myself? If no, where am I gonna get it? When am I gonna get it? Can I finish the thing within the time frame set? If you're not able to, make a simple and less complicated design situations. Okay, so make a simple product. So will I be able to make the product in the time available? If not, try to leave it down and much easy in a project that's much easier for you to do, but also easier for you to convey the story. Okay, so second is why is annotation important? Remember, annotation is the one that we see outside of the original sketches that you have, because it would not appear in your final design portfolio and so on. So how do you come up with the idea? That's your inspiration. So what material do you think should be used and why? So what are the ideas be made? Can the idea be made in time possible? Would it cost too much? Do you think your client will like the idea, and why do you choose a certain thing? So basically everything that you want to convey about a single sketches will be part of the annotation that you need to put into for your final sketches. Okay, so once you're done that, you go in, you choose one of the thing quantitatively. I'll show you how later, and you go to the next one, which is present the final chosen design and justify its selection. So present the chosen design in appropriate format, including detailed annotation that justify the choice of design by referencing the requirements of a design specification. So design specification is very important over here. So you look at this table is the one I think is much easier for everyone to understand. So if you have your design specification, let's say that is all the one that you have conduct over here. So this is your design specification. So what are the cost, customer, and so on. So if you go back here, this will be maybe aesthetic, form, customers, and so on. So you just give them a score from, let's say, 1 to 5 or 1 to 10, and so on. So you might want to, maybe in this case, they have another rubric table with the score at 1 to 4. So design 1 will have 1, 3, 3, 1, 1, and so on. So in this case, if you look at the table at one glance, you understand that it is 17, and immediately you know that design 2 will be the best design for all. Okay, so presenting the chosen design, in this case, we are trying to try something new. So we want you to make a 3D model out and present it as your final chosen design in very different in a different angle. So try to use more colors, try to use the measurement within the SketchUp software and so on, so that it's easier for us to convey how big it is and how detailed it is. So in this case, if you are doing something like an explain the storyboard, so how the video is going to look like and what is the explanation of the final design in terms of text form. So if you already have a 3D model, that would be way more easier for you to explain. So justification on the design can be done through individual explanation of the thing, or you can just explain why do you give this a 4, why do you give this a 4 and 3 and 1, why is it a 3, why is it a 1 and 2, why is it a 4, 1, 2, and why is the logo much higher than design 1 and design 3? What is the reason behind the scoring, and why do you think the final chosen design is much better than the two? And then you attach an example of the 3D model that you have done, and that will be actually done for your for your chosen design section. Then is the last part where we go into manufacturing. So Criterion B Strand 4 is develop accurate and detailed planning drawings, diagrams, and outline the requirements for the creation of the chosen solution. So what you're expected to do is to develop a series of accurate drawings that include sufficient details of the design for peers to interpret correctly and make a solution. So details include size, assembly, and production method in the drawings diagram. So in this case, they have do something like a comparison and 3D drawings over here. So what is the easier way to do it here is that because you already have a 3D drawing, it will be very easy for you to get all the details of components for what is the identification of standard components, size, scale, material, and finish. So just understand that when you're doing a 3D modeling, each of the part needs to be you need to label out the material for each of the part, otherwise it's very hard for people to understand. So once you have a 3D model, this should be very easy because you're supposed to give the orthographic view of the chair. If you're doing by hand, of course it will be quite tedious, but if you're doing a 3D model, just go scroll the window up and print a photo. Same with front view, same with right side view. So these three views give us a very clear idea of how your product is going to look like, how big it's going to be, where is everything, and how does the projection looks like from the side at the top. Okay, so the part list is basically the final part of the whole design report. Is basically just what are the part you need, what are the material you need, what the dimension of the individual part, how many quantity you need, and what are the saw required for you to get that parts into the dimension that you want. So in this case, they're using a tendon saw to saw up all the pine wood. They're using some scissors and glue to cut out all the felt, and they're using drills and screwdriver for the brass, and then some hammer and nails, some cloth and battery drill and all that thing to put all this part together. So this gives people a very clear idea on how this thing should be manufactured. And if you're doing something similar like a furniture, a table, maybe it will be a lot simpler than this. You just need a tabletop and you just need the leg. Maybe you need the screws for you to screw them in. Maybe just put tools as battery drills, files, and screwdriver. So that'll be good enough. So that's basically how the whole Criterion B should be done. So just to recap again on how the whole thing is going to work. So Criterion B has four strands. We have design spec, where you write out the expected outcome of your result, of your product based on the research that you have done in Criterion A. You draw out three different design on pen and paper with annotation. Remember, your annotation should include your dimension, your function, and your material. So try to include as much detail as you can. Things like inspiration, things like why do you do a certain thing you think, and any thoughts that you want to add into your initial sketch, also add it in your design ideas. Chosen design is basically one of the three paper sketches as above, and then you try to do a 3D modeling of it. And how do you choose the final chosen design is basically based on the design specification table. So evaluation of design against specification table. So the feedback from peers, or you can just feedback from yourself. Either one works. So lastly, we got a final design, which we are trying to explain the manufacturing process. So list down individual parts of what you need, each of the dimensions, and then how you're going to join them together in a very simple short paragraph. So appendix will be just basically your list of reference and some of the supplementary documents that you need to add. So that's basically Criterion B report. So see you in the next one, hopefully soon. Bye.